Hello and welcome to this video where we dive into the world of silica and explore its different types. This is the fifth video on a silica series which is published on Epoxy channel on YouTube. In the previous videos we introduced silica and its related products. We have also defined crystalline and amorphous silica and their subcategories. We have separately introduced crystalline silica and then we jump to amorphous silica. In this video, another class of amorphous silica belonging to byproduct group will be introduced. In this video, we will look through properties and production route of fused silica. Please stay tuned. Fused silica is an amorphous form of silicon dioxide, SiO2, also known by alternative terms such as fused quartz, quartz glass, or silica glass. It is produced by melting silica powder at high temperature until the grains fuse together and then cooling it rapidly to avoid crystallization. The resulting material is extremely pure and finds widespread use in optical applications. Fused silica, when cured, becomes one of the most important optical glasses used in a variety of applications, including bulk optical components and fiber optics. It is important to note that the fused silica belongs to the family of silicon glasses, which may contain additional elements such as soda, alumina, germina, or lime. These variations in compositions lower the glass transition temperature and alter some of the properties compared to pure silica, including transparency, range, and thermal expansion coefficient. Although fused silica is sometimes referred to as fused quartz or quartz glass, it's essential to differentiate it from crystalline quartz. Fused silica is an amorphous material, meaning it lacks the long-range atomic order found in quartz. Other names for fused silica include silica glass and vitreous silica. Now let's discuss the key properties of fused silica. Mechanical properties. Fused silica is hard and robust, making it suitable for various applications where durability is important. Despite its strength, it is not overly difficult to machine and polish, which is crucial for its use in precision optics. Thermal properties. Fused silica has a high glass transition temperature, meaning it requires significantly more heat to melt compared to other optical glasses. This property also allows fused silica to withstand relatively high operating temperatures. However, it's important to note that if the temperature exceeds 1100 centigrade, especially in the presence of certain impurities, the material may undergo devitrification, which is local crystallization into cristobalite. This crystallization can spoil its optical properties. Low thermal expansion. Fused silica has an exceptionally low thermal expansion coefficient of around 0.5 to 10 to power minus 6 Kelvin. Low thermal expansion. Fused silica has an exceptionally low thermal expansion coefficient, which is several times lower than typical glasses. This low thermal expansion is crucial in applications where dimensional stability under temperature range is important. Thermal shock resistance. The low thermal expansion of fused silica also contributes to its high resistance to thermal shock. Rapid temperature changes or high temperature gradients can be tolerated without causing significant mechanical stress, making fused silica an ideal material for environments with extreme temperature variations. Finally, chemical properties. Fused silica is chemically inert in most environments. Its purity is highly dependent on the fabrication method, but it is typically very pure. The material is resistant to most chemicals, but it does react with hydrofluoric acid and strongly alkaline solutions, which can degrade its structure. These unique properties make fused silica a versatile and valuable material for industries such as optics, electronics, and high-temperature applications. It is widely used in everything from high-performance lenses and mirrors to advanced fiber optic cables. Fused quartz, fused silica, or quartz glass is a type of glass that consists almost entirely of silica, SiO2, in its amorphous or non-crystalline form. Unlike other commercial glasses, which are made by adding various ingredients to modify their optical and physical properties, such as lowering the melting temperature, fused silica is a pure form of silica. This purity gives fused silica its distinctive high working and melting temperatures, which makes it less suitable for many common applications where lower melting points are preferred. Fused silica is primarily used in a variety of optical components, including lenses, prisms, optical flats, mirror substrates, and diffraction gratings. Some of its key advantages include a broad spectral transmission range, high hardness, and low thermal expansion. For example, fused silica is ideal for use in large telescope mirrors because it can be fabricated into large pieces without compromising its optical properties. Additionally, fused silica is commonly used in optical windows, makes it especially important for photomasks and photolithography. When compared to other common glasses, fused silica has a superior optical transmission that extends well into the ultraviolet and infrared wavelengths. This property makes it ideal for making lenses and other optical components that are needed for UV and IR applications. Now let's explore the different types of fused silica. Fused quartz is typically produced by flashing or melting high purity silica sand and contains quartz crystals. There are four types of commercial silica glasses. Type 1. Type 1 produced by induction melting natural quartz in a vacuum or in an inert atmosphere. Type 2. Type 2 made by fusing quartz crystal powder in a high temperature flame. Type 3, created by burning silicon tetrachloride CiCl4 in a hydrogen-oxygen flame. And type 4, made by burning silicon tetrachloride SiCl4 in a water vapor-free plasma flame. The melting point of silica is typically around 2200 centigrades, and this process is achieved using either an electrically heated furnace or electrically fused or a gas oxygen fueled furnace, flame fused. Fused silica can also be made from nearly any silicon-rich chemical precursor, typically using a continuous process that involves flame oxidation of volatile silicon compounds such as SiCl4 to form silicon dioxide. The resulting dust is then thermally fused to form the transparent glass. This process results in a material with ultra-high purity and improved optical transmission, specifically in the deep ultraviolet UV range. One common method for producing fused silica involves adding silicon tetrachloride to a hydrogen-oxygen flame, which leads to creation of the silica glass. Fused silica's excellent optical, mechanical, and thermal properties make it a crucial material for a wide range of high-performance optical and scientific applications. Thanks for your attention. In the next video, we continue our discussion with silica gels.